So now in this video, we're going to look at the PNP bipolar junction transistor as a current source. This is the basic layout. So it's like the NPN bipolar junction transistor version, but polarities are opposite. And so we have the transistor flipped around because we're keeping positive on top, negative on bottom, and we have the opposite chemistry for the transistor. And here is the physical component. We're using the 2N3906, and it's a good idea to make sure and check the part number, so we'll do that really quick. And if it starts with 2N, such as this 2N3906, there you can see that pretty good right there. So if it starts with 2N, whether it's NPN or PNP, the emitter is the left pin, base is the middle pin, and the collector is the right pin. And so we want to swivel it this way so that the emitter is on top and the flat side is still up, base in the middle, collector on right. So I accidentally put this in backwards earlier when I was doing some circuit testing to get ready for the video, and I was getting readings that weren't right. So even though it's PNP, which is also PNP, they have different size areas and stuff, so it doesn't exactly work completely the same if you put it in backwards, but often it does. So you may put a transistor in backwards and the circuit may work as you expect, but in this case it did not. I did not get the voltages I expected. So in any case, make sure if something seems wrong, all the components are in the right direction. So to make the math easy, we're going to use a 1 kilo ohm resistor to set the current. So as you can see here, there's a straight current path basically from the power supply through the current setting resistor and then the emitter collector to ground. And the exact current that flows depends on the voltage. So now that voltage is in relationship to the positive side of the power supply. We'll look at that later on. We'll set that with a zener. But in any case, that voltage with a 0.6 volt drop, so we're going to try to get a 5.6 volt signal for a 5 volt across the resistor. And then with a 1 kilo ohm resistor, that will give us 1 milliamp of current flowing through there, even with different loads. If we use a 2000 ohm resistor, we would get half the current. So in that case, we would get 2.5 milliamps. Or if we use half the resistance, which I used in the last video for the NPN bipolar junction transistor version, we would have twice the current flowing. So that resistor's value is half of what sets the current through the load. Now we need enough voltage. We're going to start with 12 volts here for the demonstration. I'm going to pick this apart. You know, it's pretty simple, so don't really need to for the most part, but we'll pick this apart and look at actually putting it together in a little bit. But for now, we're just going to look at that. We saw that the power supply was set to 5 volts. We'll see what's making it to the circuit, which is pretty much 12 volts. There's a little loss because of a little bit of resistance and stuff, but there you can see practically 12 volts, good enough. And we're going to set this to milliamps of current. So I already told you the way we have this set up now. I got about 5 volts across the resistor, about 5.6 volts because that is a 5.6 volt zener diode, but it doesn't seem to be completely accurate. Looks like it's a little high on its voltage. So there you can see 5.18. But the main thing is that I'm going to put an LED in series here, and this is a green LED. It blocks about 3 volts and 2.63 volts. There you can see same current right there. And I'm going to put this one in series again. And so this is about as much as we can do because we're dealing with 12 volts. But there you can see the same current may have dropped just a little speck. But in any case, we're going to go overboard now with a red LED also. And now you finally see it dropped. But as long as the load wasn't too big, current held steady. That's the main takeaway. Another thing, before I forget, is that this PNP version of the current source, you don't see it very often actually. I have a pretty hard time, not terribly hard, but I have a somewhat hard time finding schematics that involved a PNP bipolar junction transistor current source, at least simple schematics. But here you can see we have the positive side of the power supply there, and we're putting our load towards negative there. So this is an actual current source. The NPN is technically a current sink. current came through the load to the transistor and it sunk a certain amount of current, holding the current. This one, it's the source. Usually we think of the positive side as the source. So when it comes to the load, we can work our way to ground without having to think about what's over here other than what is giving us the amount of current. And that's just kind of a more natural thing to have the load across the positive side and then end at ground. And you have that there for the most part. So now, this circuit, we're going to focus on a single LED. So this is actually the setup that we had earlier. But we're going to focus on a single LED. We're going to need at least 9 volts. So with a higher load, we would need a higher voltage. And so the maximum voltage that we got here is to protect the components. And so the resistor is going to hold about 5 volts across it. And the LED is going to block about a certain amount of voltage. The rest of the voltage are going to fall across the transistor. So I tried to hold it to about 7 volts. But in any case, we need enough voltage to also light a green LED. So I think 9 volts is about the minimum. Green LEDs block more voltage than the red LEDs. So we could go with a slightly lower voltage with red LEDs. That's why I picked the green one for our minimum voltage. So in any case, we're going to set the voltage with a zener diode. So zener diodes, you put reverse bias. This is a 5.6 volt zener diode. You can see 5V6 on there if you look close enough. I think it's C5V6. They use V for the decimal point. But in any case, we're going to put that in there. And I talked about zener diodes before. I'm not going to go into that too much in this video. But the main takeaway is that is to the positive side of the power supply, because we need this voltage difference in relationship to the positive side of the power supply. Now we can use a fairly high value resistor. Remember, to actually get that voltage, you do need some current to flow through it, and it's going to build up that voltage across it, and whatever extra voltage may come along will pass across this resistor. So if we want to drop the voltage a little bit, we could actually use a larger value resistor. That would slow down current a little more and get a little less of a voltage buildup. But in any case, main thing is this is unusual. We're not in relationship to ground in this one because it's a PNP transistor. It's in relationship to the positive side of the power supply for this particular circuit. So there we have it. It was that simple. So we're going to set about 5.6 volts to the base. That is the main takeaway. The power supply is on. So that's right, we are not getting the LED lit up because we haven't connected it to ground. And so the only reason why we have this gap is just so it's easy to take multimeter measurements. For current, you need a gap for measuring current. So there we go. And we will look at those voltages right now. And there's the multimeter set to voltage. So again, it's the voltage in relationship to the positive rail right there. So it looks like about 5.8, unfortunately. And then so we will have about 0.6 volts, approximately less, across the resistor. It looks like it's about 5.1 for some reason. And so we're going to have somewhere around 5.1 milliamps of current because this is a 1 kilo ohm resistor. Again, lower value resistor will mean more current, higher value resistor will mean less current, but the voltage across it will be pretty much the same. And there you can see we have that current that we had before, even though we dropped the voltage down to 9 volts at the supply. So I wrote for the maximum voltage right there, 15 volts. And first we will quickly look at this with the green LED, and I'm going to jump this up to 15. So I wrote red LED on there for a reason. So this, we probably could go higher, but this is probably pretty close. Transistors have usually these 2N3906 about twice the wattage rating of a resistor. So with the same current going through it, you can pretty much double the voltage that it can take, and so it takes about twice as much power to get hot. So with the green LED though, we'll measure the voltage. That's why we need to have this so that it's on. Measure the voltage across the transistor. So we're going to go to the collector down here. Remember, this is a PNP bipolar junction transistor. And go to the emitter. And okay, I was pushing on the jumper. That's why. And I shorted something up. Let's move this out of the way. There we go. Now let's get the voltage measurement. And there you can see about 7 volts. So that's really about where I wanted to hold off approximately. And so I'm guessing with the red LED, because red LEDs block a little less voltage, we'll probably have about 8 volts now across the transistor. And there you can see it's quite a bit closer to 8. The LED is blocking about 1.9. So this, I'm not going into a lot of detail on the circuitry of this, so there's not much to it. And we covered the NPN version. It's basically the same, but polarities are opposite. So I'm doing a little bit more of measuring the, we could see it was about 1.8, I believe, for the red LED. And it's probably going to be about 2.8 for the green LED. As you can see there, a little more than 2.8. So green LEDs block a little more voltage. That takes a little voltage off of the transistor. It'll get a little less hot. But the green LED, even with less current going through it, it's a whole lot brighter. So had the same current though, because we're using a current source. Now, hope that all made sense. I kind of rambled on for a bit. And so now we're going to look at with 2 LEDs. So again, we got more voltage being blocked here. We need to step up the voltage for the green LED. And if we use 2 green LEDs, we're blocking somewhere about 6 volts approximately. So 1 green LED there, the other green LED here, and we will also, another thing we're going to do with this circuit, we're going to get rid of the 5.6 volt zener, which turned out to be 5.8, unfortunately, slightly higher. And we're going to grab a 5.1 volt zener diode. But we still want to try to get 5 volts across the resistor. And so we saw there's that drop before. Make sure that the cathode is to the positive side. So what we're going to do is take a rectifier diode right there. We know when it's forward bias, it blocks about 0.7 volts approximately. But whatever it is, it's the same as the base to emitter drop because it's made out of the same material. And so this is PN material, and we got PNP material. So PN, PN right there. And I didn't cover the PN very much on my diode videos, but most people do. They cover that a ton, and when it comes to actually using the component, it's not crucial. So to make my videos easier, I just kind of skip going over the PN and other stuff a lot. But in any case, now we have the 2 green LEDs, and we will look at the current. The power supply is still 15 volts right now. Let's drop her down to 11. Right there. That is our minimum, probably, that we want for green LEDs right now. And we'll get to that first, I think. Let's look at the current. And there you can see we got 4.64, which seems low. Let's look at with just 1 LED. So looks like I might have been wrong. Looks like 11 volts might have been too low. Alright, still 4.6. So what we're going to do is look at the actual voltage we are getting at the resistor, and also look across here. So So I set the meter to a voltage, and this will hold pretty steady even with the okay, I know what I did wrong. I needed to change the resistor. So we don't have enough current going through there for the voltage to build up. Again, as I said, if you're not getting the measurements that you expect, again, this is a pretty simple circuit for the most part. That's why I'm going over this simple stuff a little more. So now, I expect, we'll go back to milliamps of current. More current flowing, it starts blocking some more voltage. So this is a 1.5 kilo ohm resistor, and we'll go back to what I wanted originally, the 2 green LEDs in series. Make sure the anode, the line lead, is towards the positive side, right there. Now we will measure the current. So the power supply is set to 11 volts. There we go, 5.13, and holds the same if I skip the one LED or if I bypass the 2 LEDs. I'm touching the LED, but it's on the same row as the collector right there. So it's one node, and the current's holding steady. So their voltages add up and they build up. And so we will look at that. So we're using at least 11 volts because these green LEDs are blocking voltage. But in any case, we'll look at the voltage across the zener diode and the rectifier diode, and it's actually pretty close to 5.8 with the amount of current we have going through there. Again, if we wanted to lower it a little bit, we could use a slightly higher value resistor. I have the probes backwards, but there you can see we're actually pretty close to 5.1 volts across the resistor right there. It doesn't hurt the meter to measure it backwards. So that was about the minimum power we wanted to use voltage wise for the green LEDs. Let's actually look at that. We'll drop this down to 10 volts and see if we're still slightly above 5 milliamps of current. Right there. And I really proved everything I needed to for this video so far, and not getting any current flow. Power is on. Meter set to milliamps. Oh, this one bunched up. There we go. The 2 pins went into the same row. A lot of stuff going wrong in this video. But I hope you still enjoy. There we go. Like I said, I already covered really everything I needed to before. But there you can see we have, with 10 volts, not enough power. We can do one LED okay, but not the 2 at 10 volts. So, and it's lower voltage, less current, little less voltage build up there, little less voltage across that resistor there. So that was the green LEDs, why we need a certain amount of power. Now let's look at the red LEDs. They block less voltage, as we saw before. So I'm just going to get right to putting them into the board, and there's 2 red LEDs. And so we are going to put it to about 16 volts right there, because we saw the resistor 1 kilo ohm there is keeping about 5 volts across it no matter what. The transistor is doing that. The transistor is actually taking whatever voltage needed to keep 5 volts across the resistor. It is influenced by the LEDs in this case, whatever the load is. And so of course with no load we would have about 11 volts across the transistor, which is starting to sound quite a bit high to me. So I didn't do the math or anything. It's probably about a 600 milliwatt, so 0.6 watt transistor. I always check the data sheet to verify. But in any case, again, now we will just look at the voltages right here. So we have what we expect, a little less than 5.2 volts across the resistor. We saw it kind of varies a little bit with different conditions, but that's what we expect. With one LED, of course, the probes are backwards. It's about 1.9 volts across one, and we can go across that one too, same voltage, but go across the 2 of them, we have a little less than 4 volts. So 9, that leaves us about 0.7 volts, or 7 volts I mean, to go across the transistor. So I'll try to push these out of the way. And so that's the thing to be aware of, is to keep the transistor from overheating. You got to check its wattage, and again, it's the current going through it, which is set right now to about 5 milliamps, and the voltage across it. So I actually think we're quite safe here. I think we could step up the voltage a bit, but just quickly doing the math, I think 16 is probably about where you just want to settle. So if you want to get the official number, you could work your way up, but that's the process. The current going through it and the voltage across it. That's how wattage works, no matter what. And so if you want to be able to provide more power to a circuit, you'll likely have to do those calculations. Otherwise, it's good to just stay. 16 volts is a fair amount, and so no real reason to push it, but use that for the 2 LEDs, not just going directly to ground for the most part. So in any case, this went on a whole lot longer than I thought, and but I still hope you enjoyed it. So thanks to anybody that stuck around this long, and check out my other videos. See ya in the next one.